ओके, पिछली बार क्या हुआ था? विल समबडी लेट मी नो? हेलो। आई थिंक रैच निकल गया था एंड नाउ वी शुड मूव टूवर्ड्स रिस्पॉन्स और मे बी अ फ्यू क्वेश्चंस फर्स्ट। एक खूबसूरत सी लिस्ट मेरे पास आई थी। ओके। ओके, इस बार नाम भी है। ओके। Few questions from Vaishnavi. What does the back of timer serve in the context of RACH? We actually did not discuss back of timer till now. We will be doing that. We will be discussing it in next message, which is message 2, which is also usually referred to as RAR. This will be answered there. Okay. Second one is, how does the length of preamble influence the efficiency and performance of random access procedure? Okay, so I think it does. It seems like I have, uh, you know, it seems like that's a valid question. I have read that someplace, but I don't actually remember how it does that. Okay, so that's why I'm going to. Nah, I'm not able to find it. I'm going to Google it. Okay, so share tech note here says, why do we have multiple preamble formats? We have 64 preambles. Each can be used with a different format. Okay, so it says here, uh, why we need various PRACH format with different length in time. Okay, so we have format 0, 1, 2, 3, for example, and okay, there are some things associated with it, uh, mostly the timing related things. Okay, length of the sequence, the sequence is length of the sequence. So 0 and 1 is made up of single copies of PRAS converted in time domain. हाँ जी. So it says, share technode says that there are 4 different preamble formats, and each of them is associated with different kind of length of the format. So why do we use it? It says, first try to figure out. Okay, so it says the format 0 and 1 made up of single copies of PRACH, while the other two are twice that. Okay, I should probably tell you that I don't know. I'm just learning it alongside you. If there is something. Now let's look at a CP part. You would notice that 1 3 has much longer cyclic prefix compared to 0 and 1. Longer CP will give you better tolerance in fading environment and reducing ISI. So one use case is coming from right over here. It says we will prefer format 1 and 3 over format 0 and 2 in case the environment has more fading. Okay, last time when we were discussing which group we need to use, then Amit sir posed a question that how does UE know about the environment that we are going to apply the path loss and everything, and we came on to an answer which said that since UE already knows the cell ID and the bandwidth by the time it is ready for RACH, it knows where the reference signals are. Based on that, it can estimate the channel. So when U is ready for RACH, if it has estimated the channel with more fading, the environment is offering much more fading than than we would like. In that case, we want to reduce ISI and we would prefer format 1 and 3. Okay, and there may be some other use cases also. Answer lies in this. So whoever has asked this question, Vaishnavi, that is, I would encourage you to go through this part, why there are multiple PMs. Share technote latch LTE page, go through this, and if we still have doubts, then we can basically discuss based on that. Okay. But mostly it will come out from fading and all that only. Okay. So it says that longer TSAC will help decoding PRACH under noised condition. So noise means there is a lot of interference. Okay. So there is a lot of interference. So in that case, 2 and 3 preamble format will be better. So one use case is this based on TSAC, and the other use case is this based on TCP, which says we would rather prefer format 1 and 3. So combining these two, this is mostly seems to be based on the interference, the noise. This seems to be based on the fading. Both are based on link conditions. I hope that answers your question to some degree. This is really not my forte, so I tried as much as I could. Okay. Next is if preamble trans max is set to 6, will the UE choose distinct preamble sequences for each retransmission? That's a very good question actually. So the answer is I actually recently was having this discussion, same discussion like 3 days ago with someone, and it turns out the specification does not impose anything here. It does not say that the preamble has to be different. It does not say that the preamble has to be same. So it is left up to your own implementation as a UE. So everything is possible. There is no specific requirement as per the specification. Fine. So we are done with 2 and 3. 1 we said we will cover when we will be studying message 2. 4. What occurs when the preamble trans max limit is reached? From which stage does the procedure recommence? So, see, preamble trans max is what? Preamble trans max is a configuration. It's a configured parameter. Configuration from access spectrum. Basically, it's a RAN configuration. Who takes care of RAN configurations? It's RRC. So the network side RRC is asking you uh, to transmit these many preambles only. Okay, in case you're not getting an answer. Uh, so basically, the logical idea is that when we are at the UE, what do we think? Mac is uh, Mac is trying Ratch again and again because it has to schedule a message 3. It's trying again and again and again, and it's not getting any response. And it was also directed that only you have to only do maximum transmissions up to preamble transmax. In such a case, whose question is Vaishnavi. So in such a case, Vaishnavi ji, what do you think Mac should be doing? What would be Mac's predicament? I'll repeat again. I'll repeat again first. No, just that. I'll again. The Mac is on UE side. It has been directed. It knows that it has been directed by the RRC of network side that you have to do only these many ratches. Once these are done, there is no response. What should this Mac, the UE Mac, should be doing? Should be doing. Then what would be the point of preamble transmax? There would be none, right? If it could by itself. See, the thing is, if Mac is being told that this is preamble transmax and you have to do these many ratches, that means that this thing is being decided for Mac. Mac is no position to decide it by himself how many ratches it has to go through in case of unsuccessful ones. Right? That makes sense. Okay. So Mac is in no position. It has been now. Who may have given this parameter to Mac of UE specifically? Who would have given it? We outside in the outside world we know that it's the RRC of network, but the RRC of network must be speaking with the RRC of UE, right? And it's the UE RRC that would have supplied all the configuration to Mac and L1 and other layers also. That makes sense, right? So RRC speaks with RRC. So what should Mac do logically is that it should tell RRC that you told me that these many ratchets are okay. I can do only this much, and this much has not yielded any fruit, so I'm done. Basically, in technical sense, Mac will tell RRC that there has been a ratch failure. It will indicate RRC with a ratch failure indication or something like that. We will implement in UE that ratch has failed, and then it's up to RRC what it wants to do, whether it wants to try another cell, whether it wants to wait for some time, and so on and so forth. But up to Mac level, it's like, since ratch is a Mac level parameter and preamble transmax is ratch related parameter, we will keep this decision specific to Mac, and Mac decides that this is a ratch failure indicated to RRC, and it's up to RRC now to what to do next. Does that answer your question? I know I could have answered it in like 10 seconds by just saying that Mac indicates failure to RRC, but I think this is basically how we should see it. We will understand better what prompts what. Okay, this will come back later. Okay, next is by Tanushri. What is meant by special cell? Okay, I am so sorry, but I have never heard this term, special cell. So is Tanushri ji here? So okay. Yes, we were discussing. Yeah, we were discussing 3 to 1. Was it special cell or SP cell? Yeah. Okay, that's what I also thought that you meant SP cell. So SP cell is not special cell. SPC currently I don't. Okay, not a good idea exactly to go into that much detail. But okay, the thing is that right from the start we have been discussing about a single cell only. Okay, but it may so happen, it actually does happen that UE sometimes gets attached to multiple cells. Okay, so usually it happens that UE gets attached to multiple cells, but the other cells are specifically for, very specifically for just the data transfer. So those cells are called secondary cells, and the one that actually does the signaling procedures for the UE, for attaching the UE, and that drives all the other signaling related decisions like handover and everything. That cell is called primary cell or P cell. So there is P cell and there are S cells, P cell and S cells, primary cell, secondary cells. This concept itself is called carrier aggregation, that we are aggregating multiple carriers and providing multiple carrier connectivity to the UE. That makes sense. Now, we actually didn't stop there. We brought in another concept called dual connectivity. We said that we can not only connect UE with the LTE cell, but we can also connect it with some other RAT. So we can have an LTE groups. We can have LTE 5G group, that would be ENDC if LTE is the master connection. Then it could be NEDC if 5G is the master and the other group is uh, LTE, etc., etc. So in that case, both the groups, master cell groups and secondary cell groups, inside can have carrier aggregation. So multiple cells inside each group, each connectivity. So in that case, the topmost carrier, the group of MCG, the master cell group, which provided initial connectivity, the primary cell of that would be called SP cell, because that is primary cell and that is also serving cell. So SP cell or PS cell, primary serving cells. Yes, yes, serving cell and primary cell. Or no, it wasn't. It's okay. I actually, when I saw that, I understood that this may be the confusion, but then I also thought that maybe there is something that I don't know, because new things keep coming. So that. What is the purpose of PRH mask index? Okay, I actually keep forgetting these things. PRH mask index. Okay, I believe uh, PH mask index we are talking about, right? Let me think again. Okay, I believe it was that. I'm not sure, but you can check. PH config index, if you remember, PH config index provides you an idea that where you can do the ratch. Okay, so it indicates all the opportunities. Okay, so if I talk about this PRACH config index, PRACH config index says that, yeah, sir, I'm reaching there. PRACH mask. So PRACH config index provides you all the opportunity of RACH, right? That in here it says that any system frame and these subframe you can indicate a RACH. But sometimes what can happen, network can provide a PRACH mask index also on top of this. So PRACH config index will indicate all the opportunities, but mask will restrict it to certain opportunities. So we get the complete RACH opportunities with PRACH config index and PRACH frequency offset. A mask index on top of that can limit your opportunities, that these are the only places you are allowed to uh, allowed to send your PRACH preamble. So basically it's like it's a subset. It PRACH mask index helps you creating a subset inside all the opportunities of RACH that are available. So that may be done for handover purposes, etc. That UE may be indicated with a mask index, that okay, I maybe many ratch will be coming, contention based, contention free, etc. Yours is contention free, please send your ratch on this opportunity, so I will be in a better position to um, decode it. I will know beforehand that this is the preamble you will be using, and this is where you might be sending ratch. This is important because handover is usually happening when there is a setup already in place, call is already in place. So in that case handover happens. So for seamless transfer without dropping the call, we have to provide these extra leniencies to the UE. Does that make any sense? Let's hope it does. Yeah. Okay. So the next one is regarding UE timers and constants in SIP2. What does it indicate when T310 given as N1? What does that mean? I actually don't understand the question also. Okay, let's see here. T310. Okay, it says that when these many consecutive out of sync indications come, then UE starts T310 and stops it if N311 consecutive in syncs. मतलब basically ये है कि let's say N310 is a number like 5 and N311 is a number like again 5. So it says when there are 5 continuously bad indications are coming from lower layer, means it's not working properly, the link is not working properly, we start T300 timer. And if then 5 good ones are coming, then we are like okay, link is now better, it's all better now, so we stop it. What do we do when it is expired? So it's like bad packets were coming, but then good packets did not come. In that case, T310 will expire, and if it expires, then it goes to RRC idle state, basically from connected to idle state. And if it needs to work, then it start latch procedure itself, and we know that latch procedure helps in synchronization also. So this problem out of sync may be eliminated by putting RRC into idle state. Otherwise, if the security was activated, so this is a case if security is not activated, but if security was activated, we try to re-establish the RRC connection through RRC establishment method. So here, the method that will be employed would be simple RACH using RRC connection request necessary, and in here it will be through RRC connection re-establishment procedure. And there are other procedures like we were triggering handover, then also we start T310, and within this time the handover procedure should be completed. If it's not, then we go for re-establishment. So what was your question again? What is N1 here? Yeah, it's this one that we were discussing. Okay. Yeah, yeah, you complete your question, please. Okay, you we can also discuss it offline. If you find what your exact query is, please drop me. I don't know. So this is it as far as the questions go. Let's see what do we have in the bank here. It's already 25 minutes. I was like, I need to go in 30 minutes today. But let's see what we can do. So yesterday, last time, we were done with Ratch, and now we have the we I plan to study the response. Okay. So, random access preamble transmission, that is usually called RATCH, is an uplink procedure. Everybody agrees? Yes, no, maybe. Okay, I'll count that as a yes. And the response will be from network, so it will be what kind? It will be downlink message or uplink message. It's a downlink message. And how do we decode downlink message? What's the usual flow that you should have by heart now? You should be knowing. Mm-hmm. Mm-hmm. Okay. How, how do you? हाँ RAR बहुत बढ़िया. So as usual, we the slot arrives, the subframe arrives. Basically, it arrives and we go read PCFICH. We find out what the how big is the control region is, and we go on to blindly decode control region, and from there we find out where in PDSCH our data is. In this case, our data would be RAR because that's what we were waiting for. When we started random access preamble, we started a timer called RARSP window timer. We know that within this window, uh, RAR should be there. If it is not there, then it's a RATCH failure. Okay. And what happens if we have a RATCH failure? Can anybody tell me? When I say can anybody tell me, I mean please somebody tell me. The question is, since when we send, when we transmit PRATCH, okay, then we also start a timer called RARSP window timer. If you remember, we studied that the timer indicates that this is the response window for RATCH. If RATCH has gone out, then within this time, the RAR should come. Everybody agrees? I believe you do. So, yeah. So, what if response does not come within that window? Anji? Yeah, yeah, yeah. Come on. Somebody was saying something. Maybe, maybe not. Yeah. it might have been lost, it might have been received, and the message too may have been lost. So if we don't receive RAR within that window, what's the action item? What's the action? Are you 100% certain it should retransmit only? We will first see. Ratch. Yeah, actually, sir, we were discussing this right at the start. So, if you remember, we set the preamble transmission counter to 1 last time when we sent the ratch out. So, if the preamble transmission max is not reached yet, in that case, we will retransmit. Okay. For example, let's say you have transmitted the preamble one time by now, and transmax value is 3. In that case, we will retransmit. Okay. And if it has been reached, the maximum transmission limit has been reached, then Mac won't retransmit the preamble. And by retransmitting, I meant that it can send the same preamble as well as a different preamble. We are not retransmitting the preamble, we are retransmitting RACH. That may or may not retransmit the preamble. Okay. So, sir, yes, sir, yes, sir, yes, sir, yes, sir. It will. Actually, sir, specifications don't say whether it should be the same or different. Mm-hmm. Yeah, power increment will happen based on this power ramping step, and whether or not to retransmit will be based on preamble transmission counter. Based on these two, the decision will be made. Yeah. Okay, so that I'm not sure about. Yeah, I'll do. I'll do. Mm-hmm. Okay. Moving ahead. So that was one thing. Okay. Uh, Second thing is there may be another thing that now I'm talking about multiple use cases. Okay. There may be another thing that, okay, let's talk about that later. First one, you understand that Ratch went, there was no response during that timer expires, and we decide to do Ratch again. Okay. Now, in another important thing that I said here, we are blindly decoding the PTCCH to receive information where the RAR is. I always told you also initially that to blindly decode PTCCH, we need some kind of key. And what is that key called? Anybody? Somebody? Come on, man. At least give it a try. What is the key that I have repeatedly mentioned is needed to blindly decode control region? Really? Nobody wants to take a guess. A CFI indicates how big is the control region, but in order to decode a DCI from here, we need a key. CFI indicated what's the length of, okay, just like here. If I change CFI to 3, this region becomes even bigger. So that's the importance of CFI. But to decode this now, to read this complete data, this golden colored data, and decode a DCI from that, we need a key, an identifier. So these are the things. Yes, RNTI. Yes, we need an RNTI. Okay. So let's say UE has sent RACH and UE is waiting for RAR. It needs to blindly decode. It needs to have an RNTI at this point. Where does it get an RNTI? That is a very important question. Where does it get the RNTI here? Because no assignment has happened till now. No RNTI assignment has happened. No message till now. All the messages have been broadcasted messages. So either this RNTI has to be a part of broadcast, or there are very few, very few options. Either this has to be a part of broadcast. Okay. So we are talking about it. We need an RNTI for RAR. How do we get it? Options A, broadcasted. Options B, spec driven, mentioned in specs, so no need to broadcast, rigidly mentioned in specs. And C is, it's kind of somehow formulated. Can anybody answer me which one is? Yeah. So C. What do you mean by past? You said it's to be past. What's the meaning of past? What do you mean by past? Sent. Okay, so that is not correct. That's what I wanted to. That's what I wanted to hear actually. So yeah, you need to understand this part very clearly. So somebody needs to mute because noise is there. Yeah. Okay. Fine. Great. Okay. Perfect. Here we have we need an RNTI. In case of RAR, we call it RARNTI, and it is calculated. Okay, so what happens is that we have this formula. I think it's one plus FITID, something something. Let's see where it is. Here, RARNTI is this one plus TID and 10 into FID. Okay. Um, See, this is very simple. TID indicates the timing offset. FID indicates the frequency offset. Okay. TID is nothing but essentially the subframe number, and FID is nothing but again, as I said, frequency offset. Okay. The value of FID is 0 to 6 because those are the offsets that are allowed. And based on that, UE now knows that since these are the UE itself has kind of selected that particular RACH opportunity to send RACH. So UE clearly knows what are the values of TID and FID. So UE knows RAR and TI. That much is clear, right? UE knows RAR and TI. But UE does not pass it to network. RAR and TI is not a, you know, it's not a part of the payload RACH payload. It's not. It's not the part of RACH payload. So basically, how does network know what RAR and TI should I uh, scramble the message with so that the UE will get it? The answer is that RAR and TI, you will see anywhere that RAR and TI is explicitly signaled. Okay, it's not it's not transmitted, it's explicitly signaled. That means that this calculation, if UE can do this calculation, network can also do this calculation, because network is the one receiving the RACH. It also knows that what's the which subframe I'm receiving it and which frequency I'm receiving it on. So these two things are known to network also. Hence, network can also calculate that if I were to process this particular RACH, then what RAR should I use for the scrambling of DCI for the same payload. Is that clear now? So actually the correct answer, but just a little tweak. Okay. Now random access reception. Now let's go a bit faster. So for example, if in subframe 0, let's say PRACH in uplink, not this is the downlink grid, but in subframe 0, PRACH was signaled in uplink. Let's say RARSP window was 6. So now UE will wait in 6 up to subframe number 6, 1, 2, 3, 4, 5, 6 till here. It will go to each subframe, use its RARNTI to decode this golden part and see if it finds RAR or not. One of the two cases. If it does not find, it will start RACH again, RACH procedure. If it does find, then also there are multiple cases. Okay. So first let's see what is happening here. So this is a successful and unsuccessful cases. Timing advance command. Timing is okay. These are all successful cases. Before that, I would like to show you something else. Here. So if in case CMAC looks like this for RAR, it contains a header, okay, and then it contains the RAR payload, multiple RAR payloads. Since I told you that same frequency time resource can be used for multiple RACHs, multiple UEs with different preambles can be processed on same resource, right? So multiple responses are also a possibility. Does everyone understand that part? So here this is one resource, let's say. So multiple UEs can put their RACH on this particular resource using different preambles. If the preamble is same, then contention. If the preamble are same, then contention. But if preambles are not same, then they can be processed, right? But in that case, RARNTI is same. Understood? So if RARNTI is same, then the message 2, the response, message 2 or RAR, that can also be for multiple, the response will be for multiple RACHs, multiple such RACHs that use the same resource, meaning same RARNTI. Okay. So what network usually does is it sees that okay, these many RACHs for the same RARNTI needs to be processed, so it processes them in a bunch. Okay. Now it has a header and a payload. Okay. So what UE will does is it will start going through each header first. Each header is 1 byte, so it will go to first header. It will see whether e bit is set or unset, which would indicate whether there is more header or not. Okay. So uh, it will read e, then it will read t. T means type, what type of header it is, if it is a rapid header or if it's a back off indicator header. Okay. If it is a bi header, this is the optional header, you will see the dotted lines here. It will save bi. Okay. So now we are in the parsing RAR part. Parsing RAR. First is parse first byte to see if bi is present. And how do we see that? We see that, check this second byte, the second bit. If that would indicate whether it's a back off indicator or rapid. If bi is present, then we save bi. If yes, save bi. Okay. After that, it will go on and keep checking each byte. Each byte indicates each header. Okay, it will keep on checking until it finds correct rapid. Rapid is nothing but the preamble id that UE had sent. Okay, suppose UE had sent preamble id 37, it will search the rapid has to be 37. And how would it find it? It will see that T indicates that it has to be a rapid. And also one more thing, if bi is present, it would be in the very first byte only, it won't be afterwards. So it will keep checking up until UE finds its rapid. Once it finds its rapid, then it will go on and look for corresponding RAR. Okay, and if it has found its rapid, it will say, okay, my ratch was successful. Now I must tell you that it does not mean the ratch was successful, but UE thinks that if I find the same rapid that I had sent, then my ratch is successful. It will lift the corresponding RAR, and after lifting the corresponding RAR, it will say, okay, this is the timing advance I need to apply. It has timing advance, so it will read the timing advance that this is the one I have to apply. So Mac will provide that to layer 1, because layer 1 does the application part of timing advance. It will parse the UL grant. This is the UL grant. It contains multiple, it contains many fields. It indicates whether it needs to apply some kind of TPC. It also contains MCS that UE has to use for message 3. It also contains frequency hopping information, etc., etc., and it contains the allocation, like which RBs UE has to use. So all that information is here, because that was the point. Also, we sent ratch because we needed grant for message 3. So this is the grant which we required. And third, it is given a temporary identity called TCRNTI, temporary CRNTI. Is that clear up until now? If there are any questions, please ask right away, because the confusion now will start piling on. No? Okay. Then these are the informations that you will save. It will save bi, and it will look for its own rapid. Once it finds its own rapid, it will lift up this actual RAR payload. It will apply the timing advance command. Mac will indicate it to L1, and L1 will apply. It will parse the UL grant to get the actual grant and other parameters that it needs to transmit message 3, and it will save the temporary RNTI for now, that will be used in further steps. So if that is clear, I shall probably stop here. So this part, if you will study, you will study only this. So the answer to one question that we had earlier, see, we have not yet passed the ratch. Okay, one one use case here could have been that initial use case was we did not receive any RAR at all. We sent ratch and RARSP expired. We discussed that. So in that case, we resent the ratch. So this is the case. Ratch sent, RARSP is not expired. We stopped RARSP because we received RAR with our RARNTI. In this case, if we received RAR, but if rapid did not match, it means that cell decided not to respond to you, or maybe they didn't receive your PRATch. Either they didn't receive your PRATch, or they decided not to respond to you because there was some difficulty in admitting the UE. Maybe there was more traffic, maybe there was less processing time, etc., etc. So rapid did not match means UE responded to your RAR, network responded to your RARNTI, but uh, did not enclose a RAR payload for you. In that case, BI becomes useful. because that kind of indicates that there is a lot of traffic on the cell right now. So maybe you should back off a little bit. Okay, use this much time. Back off indicator indicates some kind of timer, a time that back off for this much time, and after this much time only you try your next stretch. So does that answer your question? I believe it was Vaishnavi's question. Okay. So that is back off indicator. Here it is seen that if RAR contains a back off indicator, you save it. Okay. Usefulness is if rapid does not match. Okay. If it's not present, then it means cell does not is not asking you to back off. Other than that, it's the same things here mentioned, that whatever I have mentioned, that if random access preamble identifier rapid is a match, then you consider this reception successful. Again, remember that consider does not mean it is successful yet. Process the timing advance command, basically applying timing advance. Indicate that this target power was successful in getting your response, because and that's because, again, as I said, ratch may not be successful. You again may need to send ratch, and you will start with this target power. Okay. And the process the ul grant and indicate it to lower layer. As I said, it contains many things. mm, okay. TCR and TI, you will again, here it is saying that this line actually means that it is contention based ratch or contention free ratch. If it's contention free ratch, this part is not useful. We already may be having CRNT etc. Let's not pay heed to this if it's too much confusing. Come here and set the TCR and TI to the your identity. I mean, use TCR and TI as your identity from now on. Okay, that's it for now. You should this you can for now avoid. This is UL sync loss case where we sent MAC control element etc etc. Okay, and again, this is the case if no random access is received. In that case, increment again the transmission counter, because we are going to transmit again. We will, okay, if the transmission counter has already reached transmax, in that case you indicate to upper layer that there is a random access problem. So this again answers another question that was asked today. And if the random access procedure was selected by MAC, then in case of back off parameter, if it is present, then you will back off for that amount of time before proceeding for another ratch. So this is all the information here that I have told you today, 5 in 5.1.4. I believe it will be easier for you to go through and understand now. Next time we will see. Why am I saying even if we find rapid, it's not next time, we'll see it right away. So it may so happen that a ratch was sent and a RAR was received and rapid also matched, but still I'm saying that this does not indicate successful ratch. I'm saying that because let's say this is the cell, this is the UE1, this is the UE, let's say A, and this is the UE-B, and both send the ratch using same resources and both used same preamble. In that case, when this cell put a response in the air for this particular preamble, then both of the UEs will think that it's their ratch because the rapid is matching. So they are now contesting, and this is why I said that ratch is not yet successful. Next time we meet, we will be studying message 3 transmission, and that's when you will be a bit more clearer on why I said so. Any questions based on what we discussed today? Yes. Yes. No, TCR and TI is assigned It's assigned by network. Okay. TCR and TI is assigned by network. That's why it's the part of the payload. So they there are certain limits of what values we can use for TCR and TI. TCR and TI is basically, it's essentially CR and TI only. It's just being, yeah, it's for now, for now it's temporary. After contention, yes, you're right, it will be promoted to the status of CRNTI. So it's essentially CRNTI, but it has a certain range that between these it has to be, uh, yeah, I think U16, its value is U16. So uh, up to 65535 it can be theoretically, but some of those numbers we use for other RNTI purposes. So some of them are reserved, and a certain range of these RNTIs is only kept for TCRNTIs. But to answer your question, yes, these are network allocated. Network assigns them and indicates to the UE. What else? Nothing else. Okay. Okay, so we can close